Take a look at this. Can you solve a problem with this kind of image? In the first place, let us understand what gave rise to this image. First, let's look at the question that produced this image and let's see how we can solve a problem using this image. This is the question. The question says, a man wishes to travel due north in order to cross a river flowing due east at 3 km per hour. If he can row his boat at 10 km per hour in still water, find the direction in which he must head in order to get to his destination directly opposite his starting point. This is what it is. We have this as the starting line for the man and this as the destination line. The destination line is here because we are told that the man wishes to travel due north. So if this is the starting point, obviously the destination line should be north of the starting line. Now we've represented that. Let's look at what is happening. We are told that the man wants to get to his destination directly opposite his starting point. Let us call his starting point O. A destination that is directly opposite it should be here. Let's call the destination point N. So if the man starts at point O and he wants to get to a destination directly opposite it, opposite the starting point, then it should be heading in this direction straight to this point N. So this is the result we want to see. This is how we want the man to go. This is how we want to see the man rowing his boat. So we can call this the resultant or the result we want to see, R. Now that we've put all of this into this image, let us see what would prevent the man from actually getting to his destination. We are told that the river is flowing due east at 3 km per hour. The river is flowing towards the east. You can see the direction. This is the current of the river. So the river is flowing to the right. If we look at it carefully, okay, let's represent this in our diagram first. If the river is flowing to the right at 3 km per hour, it means we can say the current flowing to the right is 3 on our diagram. Now let's look at what will happen if the man decides to go from point O and head directly to the north. There is the tendency that the man will be going in this direction. Why? Because the current of the river flowing to the right will tend to push the man in this direction, but he wants to go straight to point N. If he goes this way, he will end up going this way because of the current from the river. What do you think the man should do? Instead of going straight, we should expect the man to go in this direction so that as he is going in this direction, the current of the river will eventually push him aright to go directly opposite his starting point. Now we are told that this direction the man is going, he is going at a speed of 10 km per hour in still water. So he goes this way at 10 km per hour. Now, we don't know if he should actually go like this or go farther away or go closer to the north. We don't know the actual direction he must head, and that is what the question is saying. Find the direction in which he must head. Tell us what angle must he go. Let's call that angle theta. If we can find the value of theta, then we can be able to describe exactly how the man must head in this direction to get to his destination at point N, knowing fully well that the river is flowing with a speed of 3 km per hour. Looking at it, we form the image you saw earlier, and we are going to solve the problem by finding the angle theta. Obviously, this is a right-angled triangle with an included angle theta, and we can solve this using SOHCAHTOA. The angle theta has an opposite side that is 3, and the hypotenuse of the right angle triangle is 10. So if we do opposite over hypotenuse, we are definitely going to be using sine. So we can say that sine theta is equals to 3 all over 10. Sine theta is equals to 3 because 3 is the opposite of the angle, all over 10 because 10 is the hypotenuse, of the right angle triangle. To obtain theta, we will take the sine inverse of the right hand side, which is theta equals to sine inverse of 3 all over 10. You can call it arc sine 3 all over 10. If you put this value into your calculator like this, you will get an angle that is equal to 17.5 degrees. What it means is that the angle theta here, which is the direction of the man, must be 17.5 degrees away from the north. So if you are moving from the north towards the west, the man must head 17.5 degrees away from the north towards the west. So we can conclude and say the man must head, sorry, this should be 17.5, it's an error. So the man must head 17.5 degrees west of north. Go to the west from north 17.5 degrees. And this is the answer to this simple question. I hope you enjoyed this. If you did, then solve this simple one. What is the resultant velocity of the boat in the river? What do you think the resultant velocity is? It's asking us, what do you think is the value of R, the resultant velocity? Take note, R is the resultant velocity, and that is what you are to look for in this question. When you get it, put your answer in the comment section. Thank you very much for watching this video and hope to see you in the next video. Bye.